How are you all? I hope you all are doing well. Myself, Swapnil sir, and today I am here with one of the previous year question from National Defense Academy, Naval Academy, previous year question 2021. So I already uploaded plenty of the videos on my channel, which based on JEE Advanced Mains, CT, and all type of the competitive exams are there. If you wanted to see this video, you may check it into my playlist. Now, in my today's video, I'm gonna explain to you all one of the question which is from determinant and matrix chapter, and it asking NDA NA previous year question paper 2021. Now let's get started on today's question. First of all, I'm going to explain to your question and then we'll move for the detailed understanding of solution. Here in our question we have given delta. Okay, so if delta, which is equal to determinant of ABC, DEF and GHI. Okay, so this is the determinant which we have given. Okay, and then we want the value for 3 by 3 determinant again given. So first row it says that 3D plus 5G, second element 4A plus 7G and 6G. Similarly, second row 3E plus 5H, 4B plus 7H, 6H, and third row 3F plus 5I, 4C plus 7I and 6I. Okay, so it is a 3 by 3 determinant given. Delta also given 3 by 3 and this determinant is given 3 by 3. Okay, and we have to find out the value for second determinant, and options are given. First option says that it is a delta, second option it says that 7 delta, third option 72 delta, and fourth option negative of 72 delta. Okay, now let's get started today's solution. I'll go through the detailed explanation of our question and solution. In our question we have given delta is here ABC, DEF, GH and I. So it seems like that we have 3 by 3 determinant over here, and to find out the value for delta in the form of some constant number, which is quite challenging over here. Okay, so for finding such values always we have to prefer either row transformation or column transformation, because we cannot take all these operation together. We have to go through either only row transformation or go for the column transformation. Try to reduce our rows and column in a simplest form. Okay, so where you can find easily the value for our determinant. Okay, so here we can see the determinant in the form of a polynomial like a DG, AG. This type of the variables are given. Okay, and all these variables, it is quite difficult to solve it here. Okay, so even after if you're going to solve the determinant directly, you will get to the little bit difficult steps that you cannot find out your value for delta. Okay, so for that what you need to do, try to reduce our given determinant into the simplest form where you can find the value for delta inside this determinant. Okay, so now let's get start. How can we reduce this one? So it is easier to take the constant from any row or any column out. Okay, so here we can see the 3D plus 5G, 4A plus 7G and 6G. Okay, so this is the first row, this one is second, and this one is the third. Okay, now you can take any element common from any row or any column, but condition it is there that element need to be a same everywhere. Okay, now here we can see 6G, 6H, 6I. 6 is the same everywhere in this column. Okay, so you don't have anything same in a row or another column. Okay, but you do have same here in a third row, it's a third column itself. Okay, so if you're going to operate the column, then go for the column transformation. If you're going to operate the row, then go for the row transformation. Okay, so 6G, 6H, 6I. So it is possible to take 6 common from this row. Okay, okay, so this is the standard result from matrix, that you can take any element common from single row or column. Okay, so I taken 6 common over here. Then left determinant here 3D plus 5G, 4A plus 7G and G, 3L plus 5H, 4B plus 7H, H, 3F plus 5I, 4C plus 7I and I. Okay, this one is a 3 by 3 determinant remain here, and 6 is a multiple over here. Okay, 6 into 3 by 3 determinant. Now what we have to do after that, so here we can see we have little bit quite confusing steps here. Okay, try to cancel that second part or try to cancel first part. Okay, so try to cancel 3D, 7L, 3L or 3F. Okay, if it is not possible, then try to cancel 5G, 5H, 5I. Okay, now here we can see one more step. In the last column, we have G, H, and I. Okay, these three variables we do have here, and here we can see in the first column 5G, 5H, 5I it is there. Okay, so what happened if I go through the subtraction of a first column to the last column at a 5 times last column? Okay, what we have to do, just go for the subtraction between these two columns, multiply some constant here and try to remove this second part from our equations. Okay, this one is quite challenging to find out the answer, that's why we have to reduce this one the way. Okay, similarly do it here. Say GHI variable, it is same here. Okay, so multiply 7 here, subtract between these two. Okay, so you will land on this step only and this one only. Okay, so always remember, only follow the column transformation or a row transformation, you cannot follow all together. Okay, so now today we'll go through the column transformation. Okay, so already I uploaded plenty of the videos on row and column transformation, you may see it into my channel. Okay, now here we can see here, so what I have done, I apply first operation on a column. Okay, so I apply C1. Okay, what I apply on C1, in a C1 I applied C1 minus 5 times C3. So how it will we get here C1 minus 5 times C3. So C1, let's see here C1, what we have, C1 3D plus 5G. Okay, this is a C1 minus 5 times C3. Okay, 5 times C3, so 5 times G. Okay, I hope you all have understood how the first element is coming over here. Okay, 3D plus 5G, which is called, can be written as 3D plus 5G minus 5G. So positive 5G, negative 5G get cancelled. So similarly, you can apply 3L plus 5H minus 5 times C3 means minus 5H. So plus 5H, again we will get the 3H plus 5H minus 5H. Okay, this one will get cancelled. Again apply similar over here. Okay, 3F plus 5I minus 5I. Okay, 3F plus 5I minus 5I. Okay, so this one is get cancelled. So we left the term here with 3D, 3H, 3F, 3D, 3E. It is a E. Okay, not a EH. This is a 3E. Okay, that 3E term it is there. Okay, 3E. So as it is 3D, 3E, 3F. Okay, now similarly we may observe in our second column we do have 7G, 7H, 7I. So multiply 7 over here and subtract with this one. So what is the possible operation for the next determinant over here? So we can go through the operation on a first second column. So we have to follow the operation on a second column, and the operation it says that C2 minus 7 times C1. Okay, C2 we have to operate C2, but what is the operation? C2 minus 7 times C1. Okay, so 7G minus 7G plus minus 7G cancel, 7H minus 7H minus 7H cancel, 7I minus 7I cancel. Okay, so you have to multiply 7 over here and subtract from here, so it is easy step. Okay, so the remaining step you will get 6 as it is, 3D, 3E, 3F as it is, 4A, 4B, 4C it is coming after cancellation of these terms by using this column transformation, and GHI over here. Okay, now so we know that we can take any constant common from any row, but that constant need to be same everywhere in that particular row. Okay, so here we can see 3D, 3E, 3F, which is having 3 constant to E, D, E and F. Okay, so 6 as it is, 3 common over here, so we can take 3 common from here, 4 common from here. Okay, so here I did 6 common, 6 as it is over here, 3 common from here and 4 common from here. Okay, the left term here, our determinant D, A, G, E, B, H, F, C, I. Okay, this is the term left here. So as you can observe, our given delta, okay, what is the value for delta given? A, B, C, D, E, F, G, H, I. This is a 3 by 3 determinant. So it seems like that our coming answer, which is much closer and associated with our given delta. Okay, but the difference it is that the value it is here in a determinant and the value it is there in a delta, it is only changing of a row and column. Okay, so you may apply column to row transformation, and whenever you take Okay, this is the very important result in determinant. Whenever you're going to apply column to row or row to column, or if you're going to take the transformation row to column, so our matrix gives negative sign. Okay, so matrix comes with a negative sign. So if you're going to take row into column or column into row, then you have to take the negative sign there. Okay, because when you interchange row into column, matrix gives negative sign. Okay, so take the multiplication 6 3 4, it is a 72, 6 3 is a 18, 4 is a 72 as it is here. And when you interchange row into column or column into row, so that row become column here, a b a d g. Okay, so here we can see. Okay, so what do you have to do? We have to take this C1 to C2 and C2 to C1. Okay, because we have determinant A, B, C, D, E, F, G, H, I. Okay, this is the 3 by 3 determinant given. Okay, so observe this and try to convert this one into here. Okay, so first element is A, so convert row into column. Okay, so when you convert replace C1 to C2, then we will get the negative sign over there. Okay, when you replace C1 to C2, you will get the negative sign. Okay, so replace C1 to C2, so we'll get the negative sign, and then take a transpose column to row and row to column. Okay, and whenever you are taking column to C1 row to C2 and C2 row to C1, you will get the negative sign over here. Okay, negative common, and then left over here with the only transpose. Okay, so 72 into negative 1, which is a negative of a 72, and this is the value which given the delta. Okay, in our question. So our correct option it is here, option number D. Okay, so option D is correct here, which is a negative of 72 into delta. Okay, so nothing is difficult here. I hope you all have understood everything. Okay, so it is only the question which is based on determinant matrix chapter from the NDA NA 2021 question paper. Okay, so after that, if even after you found anything difficult, let me know in comment section. I will come up with the similar videos. So thank you everyone. Thank you for my today's lecture.